Hello, everybody. How are you all doing? Good. So, before I begin, I'd just like to ask a quick question to the audience. So, if you can put your hands up if you've ever been so scared in your life, so frightened, that a little bit of pee has come out. Okay, keep your hands up. Okay, you can put your hands down. So that was about 25 to 30% of the audience. And hopefully, by the end of this talk, that number would have increased. Because today we're going to talk about web security and hacking. So who am I? My name is Asim Hussain. On Twitter, you can find me at JawAche. I blog about Angular and JavaScript, and I teach Angular and JavaScript through my site, codecraft.tv. And I'm also what's called a cloud developer advocate at Microsoft. So I work with the Azure team, and I'm kind of like a conduit, a short circuit between developers like yourselves and the PMs and developers in Azure. So if you want to come speak to me afterwards and complain about Azure, go right ahead. But to begin, I'd like to tell you a story. The story of my first startup. So at the time, I was working in investment banking in Morgan Stanley. It was a really good job, highly paid, good career path. But I had a side project, a website called Event Sushi, which aggregated events from Facebook, Meetup, a bunch of other places. And it was going slightly okay. So obviously, I gave up this wonderful job, highly paid, did I say that? And I quit everything, and I started working on this thing full time. And I was really arrogant at the time. Did I mention I used to work in investment banking? Yeah. I was very arrogant at the time. So those investors interested in giving me money right at the start, but I was like, no. This is going to be $1 billion startup. I don't want your money. I want 100%. I think you can guess what happened. 6 months later, I'm running out of money, my money. I had about 3 months of money left. And I don't mean investors' money, I mean my money. I didn't have enough money to pay rent. So I started to get desperate. And the investors could see that. So they started backing away. Apart from one guy. We've been talking for 6 months, and he liked me. And he said, listen, Asim, we've been talking for a while, I like you. Just give me a demo in 7 days. And after that, we'll just work on the investment. So I was like, yes, almost going to survive. But then 48 hours before I was supposed to have my demo, I got contacted by Linode. Has anybody heard of Linode before? Okay, so they are like infrastructure as a service. They provide you a VM, a virtual machine, and you install the operating system, the web browser, the web server, and your application. You basically host your application using it. And they said, Asim, we think your website's been compromised. We think your server's been compromised. We can see it's making lots of different requests to other servers, and if you don't fix the problem in 24 hours, we're going to shut you down. Just a reminder, I've got a life-saving meeting in 48 hours, or I'm going to get shut down in 24 hours. So I panicked. But I logged onto the server, checked the temp folder, and I found something very strange. The www data user had some folders in there, in the temp folder. And then there was a large file with what looked like lots of IP addresses. Another large file, which looked like lots of common passwords, and a shell script that was trying each password with each IP address. I could have just deleted that, but I knew Linode wouldn't have believed me. I need to find the root cause of the problem. So I spent a bit longer investigating it. And I saw this PHP process running. I'm not a PHP developer. What's PHP doing running? And then I remembered when I first set up the server, I'd installed WordPress. Yeah? got rid of it straight away, but I forgot to remove it from the start script. So that when the server restarted, PHP started, and the hackers got in through that. So, just in resolution, basically I fixed the problem, deleted the folders, removed PHP from the start script, spoke to Linode, they were happy, they let me keep on running. I had the meeting the next day, and the investor invested. The startup still failed, but I survived for a bit longer. So, now I had read up on security. I'd followed all the instructions. I'd locked down root access. Every single process was running under a different user. There was firewalls set up failed to ban. I had done everything I thought I had to do, but they still got in. I don't think I really did anything that stupid. So if it can happen to me, it can happen to anyone. So I love stories, as you might guess. So today I'm going to talk about hacking. I'm going to talk about hacking through a series of 4 stories. Some of these stories are specific to Node, some are more general web development. But each story has a moral, a lesson that you can learn, and also perhaps some steps you can take to protect yourself. So let's start off with breaking down exactly what happened to me when I got hacked. So just to make sure everybody's on the same page, let's explain a few terms. So a vulnerability is a hole in your security. Okay? So for instance, not setting up a firewall is a vulnerability. Okay? An exploit is a tool, a piece of code, or just a sequence of commands that you run which take advantage of a vulnerability to do bad things. So who here has heard the term zero-day exploit? Okay, fair number. So a zero-day exploit is an exploit that no one's heard of before. It's a secret. So white hat hackers and black hat hackers. So a black hat hacker is somebody who hacks for personal gain, considered the bad guys. If they have found a zero-day exploit, they might sell it to a criminal organization. A white hat hacker is considered a good guy. If they found a zero-day exploit, then they would inform the company privately, let them fix the problem, and they won't tell anybody until a patch has been released. So once that exploit has become known, it's not a zero-day exploit anymore. It's in the public domain. You might call it a 1-day exploit, or a 30-day exploit, or a 6-month exploit. How hard do you think it would be to get a hold of a 0-day exploit? Hard, right? You're going to need to be in the right circles. No one's just going to give you a 0-day exploit. You need to be the right kind of people. How hard do you think it would be to get a hold of a 6-month exploit? Pretty easy, right? In fact, it's very, very easy, right? You can just find it on the internet. This is one site called ExploitDB, and this is how easy it is. Search PHP, it's got a reCAPTCHA. Hit search and have a look at this. Look at all these exploits. Have a look. They're all on the same day. We're still in 2017. PHP is not very secure, by the way, people. So we all think hackers look like this. Who knows this? Yeah, Mr. Robot, right? Black hat, mysterious, computer geniuses. I mean, why would Mr. Robot bother with me? Why would he bother hacking me? I'm a small startup. I'm losing money, But they weren't after my money. They weren't even after my data. They didn't get access to my database. They were just using me as a node, as a server from which to launch other attacks. Okay, they didn't care that Linode was going to shut me down. They didn't care I was going to lose everything. And that's the thing. I don't believe the people who got onto my server were genius black hat hackers. I mean, they didn't use a zero-day exploit. I was using an old version of PHP. They Googled how to exploit me. They just followed instructions. It's not that hard. In fact, it's even easier than that. You don't even need to do this whole thing manually. Okay? There's tools that automate the whole process. This is one. It's called Metasploit. And basically, it's a command line tool. You point it towards a website, scans it for vulnerabilities. If it detects the vulnerabilities, it's got a database of exploits, and it can just hack you automatically. I'll make sure I got this statistic right. It's either 14% or 27% of sites can be hacked automatically. So what can we do? Okay? We're still vulnerable to zero-day exploits. You can't protect yourself from things you don't know. But you can protect yourself, defend yourself from exploits that are known just by keeping your software updated. That's it. It's really easy, right? We just need to make sure to update our operating systems every single day. And, oh yeah, I'm using web servers. Just need to make sure I'm updating my web server every single day. And I'm using databases. I need to make sure I'm updating Postgres and make sure I keep that updated. And, oh yeah, I'm also using nodes. So I've got to make sure I'm keeping all my node NPM modules updated every single day. And, oh, I should also listen to the security bulletins in case they give me a patch so I can apply that patch. Actually, that sounds like a lot of hard work. It doesn't sound easy at all. And I'm a node developer. Okay, my job is to write applications, not to maintain server software. So after my attack, I started exclusively using PASs. Okay, just an explanation of what a PAS is. You can have kind of on-premise, which means that you have a server, you stick it in a data center. If the hard drive fails, you have to fix it. Also, you're responsible for the operating system, keeping updated. You're also responsible for like the web server and the database, everything. That's up to you. And of course, your application itself. Okay. Then we have infrastructure as a service. That's when you might get a VM, just a virtual machine. They handle the hardware, but you're still responsible for the operating system. You're still responsible for the web server, the database, and the application itself. Or you can use a PaaS. It's a platform as a service. They handle the hardware, they handle the operating system, and the web server, and sometimes the database. You just focus on your application. That's it. And the great thing about PaaS is that they do all the patching for you. They have teams of people. All they do every day is just figure out what security holes there are out there, keep it all updated. And there's a couple of them out there. I've used Heroku a lot. Google's got Google App Engine. Amazon has Amazon Beanstalk. I haven't really used that much. And Azure, my company, we have Azure App Services. Whichever one you use, doesn't matter. I would just say use a PaaS. Oh, and if you use Azure, one of the coolest things I think about Azure is something called the Azure Security Center. So like, when it comes to hacking, there's loads of little signals, there's loads of little hints everywhere that you might have got hacked. But if you're alerted on all of those, you'd just be too much noise. You just start ignoring everything. So what we did was we built an AI. We trained an AI. We fed it lots of real hacking attempts and not hacking attempts, all the signals. And now we basically built an AI that can chain all the signals together and alert you. I mean, it's not perfect, but I'm lazy and it doesn't require any effort to use, so I like to switch it on. Does anybody know this show? Yeah, one. Oh, there's not many of us, are there? Two, yes. This is my favorite show in the whole world. It's called It's Always Sunny in Philadelphia. And this is a character called Charlie Kelly. He's the dumbest character on the show. He cleans the toilets. But he watches a lot of law shows, so he thinks he can be a good lawyer. So every time in the comedy show, there's he always represents himself in court very, very badly. And that's what I think. So my closing arguments to this statement is that thinking you can create a secure platform to host your application when you're not an expert in security is like thinking you can represent yourself in court when you're not a lawyer. Charlie Kelly. Okay, did I manage to scare any of you? Probably not. Maybe the next story will scare you a bit more. So when you register a company in the UK, you have to register it with the government. I have a company called Dale Revo Limited. And you can go on a website and search everybody's companies. This is an actual company that exists in the UK. Semicolon, drop table, companies, hyphen, limited. So what is this? This is an example of an attempt at something called an injection attack. Something specifically called a SQL injection attack, because it looks like SQL. And an injection attack, the point of one, is to run untrusted code in a trusted environment. So the goal is to trick an application into running this SQL. How might that work? Well, if you're not very careful, you might have a script which looks all the companies in the company's database, select star from companies where name is equal to, and you put the name of the company. But if you put that name in, this is what would actually be generated. Select star from companies where name is equal to nothing. That statement is nothing will happen. Then drop table. Drop the table, the company's table. And then this is just a comment, so it's ignored. But remember, name might come from something else. It might come from an input field in a form or a field in an API endpoint. It can come from anywhere. And you might ask, so what, Asim? I've backed up my database. I don't care. I'll just restore it. But drop table isn't the only command you can run. And in fact, you don't even have to do anything. You can do the whole thing with SQL map. Automatic SQL injection database takeover tool. Takeover tool. Such a common vulnerability that there's actually an automated tool which does it for you. You might see a pattern emerging here. So let me just show you it running. Here we go. It's a Python script. Hopefully you can see it. So you pass in a URL of where it might be vulnerable. This is an endpoint here. It first kind of does a scan, tries to figure out things like the database version, what database software you're using. And it's figured it out. It's MySQL with PHP. And then now it's going, okay, it's MySQL. Let me check it with a set of common passwords. Oh, it's found the password. Then it's going to check which tables we've got. There we go, users table. Let's dump the users table. Okay. How long has it been so far? Not long. And then it gets even more scarier because you can actually run shell commands. Who am I? ls, cat, etc. password. Okay. So in about a minute, less than a minute, I'd say, we can get access to the database, dump the users table, and even run commands on the OS shell. Scarier? So what's the moral of the story? So don't assume your inputs will come in the format that you expect. Okay? What's the solution? Well, the solution generally to all these injection attacks is, well, for a lot of these kind of attacks, something called sanitization. Okay? You've got untrusted input, you need to sanitize it. If you're using Node, and you're using a SQL expression, you've got SQL string, you pass your untrusted string to there, and we'll escape all the dangerous things out of that string before you run it in a SQL statement. And there's There's all kinds of injection attacks. There's all types of different sanitizers that you can use. And if you're using something like the Azure SQL database, it automatically, I love the word automatically, by the way, it automatically detects SQL injection attacks for you. It doesn't stop them, it just alerts you of them. So how are you feeling now? I mean, I showed you something I think pretty scary then. You a bit more scared? No? You okay? You like horror movies? All right. Maybe the next story will scare you a little bit more. Who's heard of this company? Yeah? They're pretty big. So this is GitHub. Hopefully we all know who GitHub is. GitHub has something called a bug bounty. So they basically pay you if you find a security hole in their software. And there's a great exploit found in GitHub Enterprise by a user called Orange Tsai. I think I'm saying that right, Tsai. That's his Twitter handle, or his or her, or shouldn't say gender. And it basically gave a hacker the ability to run any command on the GitHub server. And they did this in a really interesting way, basically by chaining a series of smaller exploits together into one larger exploit. And who likes heist movies? You know, movies where they rob a bank? I love heist movies. I love figuring out how they did it. And that's what I love about this story, is that there's a really great explanation of figuring out how he did it, and I'd like to share that with you. So, you've heard of webhooks with GitHub? Okay, so in GitHub you can set it up so you have a webhook, so when you do a git push, it does a post request to a URL which you define. Fairly straightforward, right? See some people laughing. Well, what happens if you, instead of example.com, you'd localhost? Yeah? Well, then you're basically posting back to yourself. And remember, you're behind the firewall now, so there's no security here. But this is GitHub people. They use the sanitizer. That URL is untrusted input. So they sanitized it. Okay, so localhost wasn't allowed. But they forgot about zero. Okay, so on some systems, zero resolves to localhost. But, you know, what can you do with that? Not actually much, as it turns out. So 9200 is the port for Elasticsearch. You know Elasticsearch? And you can actually shut down Elasticsearch by issuing a post to the shutdown endpoint. Okay. But that's about it. That's all you can do, really, with this exploit right now, is do a git push, shut down Elasticsearch. A little bit annoying, right? But nothing too serious. So Orange spent a few more days looking into this. And then found this piece of code. So GitHub Enterprise, the package, also uses something called Graphite, which is like a charting system. And it's open source, so they could look at the source code for it. And found this function in it. It's all in Python, I know. I'm sorry, we're all Node developers, but we should all be able to read it. I'll just highlight bits that are important. So it gets the URL from the query parameter. Oh, grabs a path from it. And does a request, a GET request to that URL. Stay with me. So then if you set a webhook URL something like this, the blue is the bit that posts. So we're posting to port 800, which is Graphite. It's calling the send email function. We're passing in this URL. Then Graphite is then going to do a GET request against the second URL. But we've done nothing super special here. Still pretty simple. All we've done is converted a post request to a GET request. That's all we've done. But that second GET request from Python uses this thing called HTTP connection library in Python. And that has a known vulnerability. Something called, I'm going to hopefully say this right, carriage return line feed injection. So carriage return, \r, is kind of the Windows way of saying a line ending, \n is everybody else. So carriage return line feed is kind of a cross-platform way of issuing a new line. And you can also convert it to hex code, ODOA. So then what happens when you set the URL to something like this? Okay. See these special characters here? Hello, foo. But what actually happens when you make a HTTP request? What actually happens? We're just basically doing a TCP connection. So we open up a port to 1, 2, 3, 4, 5. And then we're passing these strings, all of them ending with carriage return line feed. But HTTP connection lib converts these to new lines. So now what are we doing? Yeah, we're opening up a port, TCP port to here, passing in that, then passing in something it doesn't expect. If that port is a HTTP server, it would go, this isn't a HTTP message, malformed, get rid of it. But what if you did something like this instead? Does anybody know this port number? No? It's Memcache. So Memcache is a caching solution. It's very, very popular. At least I remember it as being the most popular caching solution for web developers. And what's this stuff here? That looks interesting. So let's have a look what's happening here. Remember, all that library is doing is opening up a port here, sending this first command to that port. Memcache is like, get what? Error. Ignore that. Gets a second line and goes, set key. Oh, I know this. I'm going to set a key. The key is key, and the data is data. What have we done? What we've done is called protocol smuggling. Okay, we've taken a HTTP request, smuggled some other data in there, and started doing TCP requests on another protocol, the Memcache protocol instead. Okay, it's about to get very scary, guys. So as developers, we like to store things in Memcache, don't we? Yeah? But, we're all really lazy, so we like to use libraries to store our data in Memcache. And we might use one which takes an instance of a class, serializes that to a string, stores that in Memcache, and then later on we get the string, deserialize it into an instance again, call a function, and we're happy. But I've just showed you that they figured out a way to change what's in Memcache. Okay? So now you're saving your instance in Memcache, your instance of your class in Memcache, you're happy. You request it back again, you think you're going to get your code again, but you're not getting your code again. You're getting my code. You're going to run a function, my function, not your function. So scanning the keys that you can see in Memcached. They found, when you use one of these libraries to serialize an instance of a class, it will put the name of the class as part of the key. So they found this one in there. See that red word? Instance variable proxy had a known vulnerability. So they added deprecated to the front of it. You're not supposed to use it anymore, but they used it. Okay? They carried on using it. So that was easy to hack, basically. Instance variable, the reason it was deprecated was instance variable proxy has a vulnerability where you can change some of that serialized data so that when it comes back, it executes a command on the server instead. Just executes a command on the server. You reserialize it into an object, executes a command on the server. Can you see this? So this is basically the full webhook URL that you've got. The red stuff is that very, very first exploit. where just by putting 0 and a git push, you can issue a post. Ooh. The second one here is we're turning that post, into a get. I don't know if you can see this here. I can barely see it. Set. That's the key in memcached. And then depreciated instance variable proxy. Let me find the code. Source. There it is. ID. That there. That's the command it's going to run on the server. Just show you this is what they sent to GitHub to prove that it was working. GitHub Enterprise. Go to your repo. Settings. Hooks. We need to add a webhook. Runs a script to get the URL to paste in. And to activate this, you basically need to do a search, because doing a search requests the data from memcached. So the kind of key thing to look here is that terminal there. Just does a search for anything, actually, anything at all. And then ran the ID command. We showed git. Pretty scary, right? Yeah, we get in there. So what's the moral of this story? Well, I think the moral of this story is that big exploits come from smaller exploits. So we think that attacks are going to come in through one giant hole in our software, and they're not. They're going to come in through a series of smaller exploits chained together. There was only one issue here with GitHub's own code. The other 3 exploits were with other third-party software. So if you found a vulnerability in your code and you're like, meh, it's not that big a deal, it's only a small one, no, fix it. How you feeling now? Yeah, anybody need to go to the toilet? There's some WCs outside. Maybe not. Maybe after the next story. Don't know if you can see this. So who can tell me what this code does? Process.env, base 64. This takes your environment variables and converts it into a base 64 string. Let me show you some more code. What's this doing? Yeah? What's this? That's my domain. I seem to be taking your environment variables, turning it into some post data, and posting it to me. So if you ran this on your server, you'd be sending me all of your environment variables. So who here stores private stuff in environment variables? Connection strings, secret keys, usernames, passwords, etc. Yeah. What if I told you I could make you run this code on your server? Would you believe me? Yeah? Maybe this gives you more of a hint. The name of the file is package-setup. So it's some sort of setup script. Yeah, some nods in the audience. Maybe this gives more of a clue. This is an NPM module. This is a setup script from an NPM module. So if you were to install this NPM module, you're going to give me all of your environment variables. But I know what you're thinking. You're thinking, okay, Asim, if I was to install your NPM module, then okay, you'd get my environment keys. But why would I install your NPM module? So who saw this tweet a couple of weeks ago? Anybody? A couple of hands. Oh, a couple more hands. There we go. So CrossEnv is a package made by Kent Dodds. And what somebody did was cross-env is the real one, and they created CrossEnv without the hyphen. Did exactly the same stuff, except that CrossEnv posted all of your environment variables to hacktask.net, hacktask server. It's called typo squatting. I mean, That scared the crap out of me. Because how many times have you sat there going, what's the name of that NPM module? I'll try it without hyphens. Oh, it worked. Excellent. Like you move on. So many times. So many times. But think about it. When you're running npm install, you're basically giving another developer the right to run code on your server. Behind all of your firewalls, behind all of that wonderful security that you set up. So what's the moral of this story? I think the moral of this story is that we're too trusting. But I've tried to ask myself the question, why? Why are we so trusting? Why is this one issue scared me so much? And I think it's because it was open source. Like if somebody came up to you and said, oh, I'm going to give you a secret binary package. I only have the source code, and just install it on your server. You'd be like, nah, no thank you. But we're just installing stuff that's all in the open source, in the open source world. Like we think the developer that created that was a good person, you know? We think that there's multiple eyes looking at it. So there's no way there can be an exploit in there. But this stuff remained up for 2 weeks before they found it. 2 weeks. And it's not even the fact that it's used in the environment. You know, if in Azure we use something called Key Vault, which is kind of we don't always recommend storing stuff in the environment, and you can store something in a much more secure place like Key Vault instead. But that wouldn't even solve this, because you're basically giving somebody permission to run code as if it was you, and your code can access Key Vault, so that wouldn't solve this problem. So what's happened? So npm have taken down CrossM, they've taken down all the hacktask modules, but maybe you've got it installed. And I've got some links at the end of these slides. I'll share these slides out at the end. Instructions you can follow to perhaps find out if you've installed one of these modules, and things you can do to protect yourself in the future. And npm are looking at kind of ways in which to do perhaps some static analysis on some of these npm modules, figuring out if it perhaps has some of this malicious code, but that's pretty hard to figure out. And the npm ecosystem is huge. So what I can say is basically double or triple check that the modules you're installing are correct. Yeah. So what's the takeaway from all of this? I say stop pretending. Stop pretending that because you spend a few minutes thinking about security that you're safe. There's people out there who spend all day, every day, just thinking of clever ways to get around your security. So use a PAS. That's my advice. So don't assume people will use your site as you expect it to be used. Okay, sanitize. Sanitize your imports, and also sanitize your outputs as well if you're putting something in some HTML. There's no such thing as a small exploit. Okay, a small vulnerability that you can ignore. Things get chained together into larger exploits. So fix them. And, you know, did the npm thing scare you? Yeah. Did the memcache thing scare you? I've always trusted stuff I put in memcache, never thought about this before. Yeah. So don't trust anyone. Okay? I don't have a solution for that, so I just put a unicorn. And like, if you want to do something follow on from this and learn a bit more, you can take my colleague Brian Clark. He has a course on Pluralsight, Getting Started with Node Security on Express. If you want to grab that, there's a link here. Again, I want to share this out on Twitter later on. And then, yeah, if you want to, again, that's my name. If you want to follow me, this is what I look like from behind. And you can follow me on Twitter, and I'll be posting the slides out later on. And thank you very much. Thanks.